Yeah, I guess we'll do some comments and then I'll have to, I guess, re-explain it to Hoffaday because, yeah, we left a comment like somehow we still can't get it. Alright, so we're going to have to explain it again. But I'll deal with a couple other comments. Flapjack Batter said, 10 gigahertz signal, 1000 megahertz modulation. That means it's 150 kilometers between maxima and minima. Yeah, that's if you're just going with the 100 hertz signal. So, no, I'm not arguing that the 100 hertz signal is what's being, like you can tell the difference at that distance. Obviously, at 2 feet away, you're not going to be able to do this experiment. No matter whether you're using sound or whether you're using photons. So it's really not the subject. So I guess I won't bother with the rest of it. The point is that the carrier is carrying the audio information, and it's carrying it as a volume of photons at a time interval. A volume of photons at a time interval. Yeah, and the time interval changes when you change when you have two sources and they're going to you're listening in a location where the distances are different. There's going to be a difference in the signal. The signals will change because of the distance, and the signal that's changing is the 10 gigahertz signal, but it's carrying the audio signal, so the changes to one will affect the other. Alright, let's see. So this was a sort of interesting comment. Is it possible to show the correctness of your double slit theory by having a gas inert or some type of envelope with two slits? The idea being the gas would not disturb the photons but might illuminate the interference or tension happening at the slits. Well, the problem is the nanometer frequency, 800, 400 nanometers frequency wavelength of the light is going to make that really difficult because any interference is happening in such a short amount of distance. So you can't disprove the interference happening at the source. But clearly I thought of that in the sense of using like a water tank, and then you could see the laser beam go in, to make the laser visible if you use even a smoky room. Then at least you would see how the beams of laser light are being sort of split. And it might be more, it might illustrate better that there's no waves of light, there's just beams of light. But it's like I said, it's you can't get to the tolerances you need to create a proof. But might illuminate the interference or tension happening at the slits. I believe this would shoot down wave particle hand waving. Yeah, well, I'm going to shoot it down one way or another, and I think the more you demonstrate how they're contriving experiments that are deceptive to defend their theory, is just more evidence of how weak it is. That there is no real evidence that any of this wave crap happens. I'm an old fella, so blast away if I'm wrong. Well, I don't know if you're wrong. I'm just saying I don't think light's going to help. Now, another guy pointed out, well, why not charge the slits? And I've already pointed out, first off, they're grounded to each other, so it's really hard to put a charge on them, unless you're made out of glass or something, an insulator. But they're so close together. The breakdown voltage is so low that you really can't put a charge on slits that close together. Alright, so yeah, that's it, I think. Yeah, so we'll do a Hoffaday. Well, that was clear as mud. Right, like your video was perfectly clear, which it wasn't. It wasn't even on the subject 87% of the time. You weren't even on the right subject. I guess I need not bother with an hour-long video until you can be more clear. So I don't even know what that means. But fine, don't bother at all. It would be fine with me. Okay, you're wrong. I'm going to prove you wrong. I have already proven you wrong. I've already demonstrated you to be a fool who thinks the magazine articles don't tell you when there's images that are composites of two different images. They just fake images all the time, and you think that's a defense of science. We're not talking about shit publications. We're talking about supposed to be science publications, and they don't inform you when the images are fake. and you think that's good. That's good science. You think it's good science to do an experiment that shows something, but shows it for the wrong reason. So you know it's true, and so you can try an experiment that shows it to be true, but your experiment has nothing to do with it being true. In the sense the experiment is just having the same result for the wrong reason. You think that kind of logic wins in science. You're a fucking idiot. Until you're more clear and explicit what the fuck you're talking about. Well, I think I was pretty explicit in the correction video that you're writing this comment on. So, I mean, I made it kind of clear, alright? I mean, you can't have a wave if there's nothing to compare the water to, right? I mean, if it's all flat, there's no wave. So the only part that's going to be a wave is where there's something too high or something too low. So there has to be something to compare everything to say, oh yeah, that's an up wave and that's a down wave. You have to have a reference of some kind. And so that's essentially what the sine wave is a reference. One side's the reference, the other side is telling you what your positive component is. The other side is telling what your reference is. That seems pretty clear to me. Alright, anyway. I'll say this, the antenna is tuned for microwave frequencies. Well, again, the antenna isn't tuned for anything. The circuit is tuned for it. It doesn't look for lesser amounts of photons. No, it does. It looks for any amount. It measures every single photon that hits it. It says, yes, I received a photon. So that's just bullshit. Sorry, you're wrong again. Or compare with empty spaces, what the fuck. So you don't understand that when the traditional drawing of a radio antenna even, I mean, it's just used all the time. I mean, you know, you can't really miss it. Every time waves are somehow modeled, this is how they're modeled, is that you have your antenna and that the waves come out like this. Okay? Indicating there's a peak and a trough. A peak and a trough. A peak and a... See, this is the trough here, Einstein. Okay? And what's happening is the second signal comes in and it puts a signal on the trough. So now there's a signal on the trough. So now the trough is saying, hey, the low water mark is now a high water mark. And so if you want to record you want a difference between these two, that's what the thing is looking for. It's looking for a difference between here and here. That's the distance it's looking at. That's what it's tuned to. It's tuned to this distance. So it's saying what's at this point and what's at this point, and whatever the difference is, that's what it's saying the signal is. So when the two get out of phase, and the one wave bleeds into the reference phase, then this receiver is going to say, no, the zero is now 300. So if you're 600, well then you only got 300. This is only a 300 wave. Even though there's 600 photons came in, it's only going to consider it 300 because the thing it's comparing it to, the trough, is 300. I mean, that should be enough of an explanation, but probably going to need more. So we'll read on. Let's see. What the fuck are you talking about? I'll say this, the antenna is tuned, okay. Doesn't look, what the fuck? Now, how on earth does this intelligent receiver manage to pull off what you're proposing? So somehow he's saying the receiver has to be intelligent to understand it's being vibrated. And that it's being vibrated based on how hard it's being hit by the photons and how far it can rebound, let's say. So you just have to think about, well, if 300 hit it, and then 600 hit it, okay, what's the rebound going to be is the total of that, right? And so the same thing works in the sense that if you understand that the first hit is going to be counted and the second hit's going to be subtracted, then you'd understand what I was talking about, because that's what it's doing. The circuit knows that it's comparing a peak to a trough, so it's subtracting these numbers, not adding the numbers. That still isn't good enough? Let's see if there's some other... I drew it the other way, and I can draw it the other way again. There's the two signals are coming in, and they have different peaks and troughs. And one of the signals is going to be the one that's going to be the measuring frequency. So the timing cycle of the receiver can be anywhere. Okay, it's just knowing, so just assume that these little red lines I made are all equidistant. It just says I'm going to take a certain hunk of what's coming in and I'm going to measure that hunk. Alright, now what the circuits usually do is they go whichever signal stronger will be the timing signal. So if, let's say, they're a little bit out of phase, so the second signal is half in the trough and half on the peak, okay, it's going to sit there and either go with this signal as the timing signal or this signal as the timing signal, but one of them will win that battle. Now once it's been established which ones, let's say this one won the timing sequence. So the timing sequence is going based on this black thing here. And the timing sequence is how many photons came from here to where the beginning of the next wave would be here. So how many photons came in this location, this amount of time. Now once this signal bleeds into this one, alright, that's when you're going to start subtracting what the reference is. Okay, I still got to get to the point where it's taking them at half cycles. So it's measuring this and then it's comparing it to this. So I'm misleading to say that it's just counting it as a whole. It's counting it as, I gotta say this so carefully. Alright, so what comes in is say it is at a half cycle, because that's the perfect confusing thing. Alright, so it's half bleeding in. And say this was a 300 dense photon, and this was, say, a 900 dense wave. So you have a density of 900 plus 300, but you only have half of the 300, so only 150 is going to get added to this bit of the timing cycle. So this bit of the timing cycle has 1050. This half of the timing cycle, which is the reference half, has 0 contribution from this wave, and it has 150 contribution from this. So now it's going to subtract that 150. So then it would go back to being the regular, it wouldn't have any effect on, and it would just let this signal pass as if this was the original signal. That'll be the only difference. So I'm just saying it's just an addition process. It's just taking the two references, this and this, and it says subtract one from the other, and that'll give you the strength of your signal. So the strength of the signal when there's nothing here is this signal. When they're out of phase and there's another wave that's producing a signal here, if it's producing the equal amount, then there's no signal. They cancel out. And that's when you have the destructive interference, when you're at just the right distance from the emitters. So when this distance, okay, is a wavelength, half a wavelength, then this location will create destructive interference. And every time this thing does something, the reference wave is wiped out, so it's nothing. There's no difference seen in the circuit. It's just measuring the difference between this second and this second, and then this second and this second, and then this second and this second. It's just measuring the difference between those two moments in time. So that's the calculation. So if the photons are just coming in blobs, let's just say they're blobby little block dots, dot here, dot here, dot here, dot here, dot here, dot 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 dot, just a bunch of dots. The circuit's just saying this is the timing cycle I'll look at. So I'll compare this to this, and that'll tell me what the signal should be. So if there's 15 here and there's 10 here, then the signal's 5. And then it's going to just take this hunk and this hunk, and it's just going to compare the two. And so there's 20 here and there's 5 here, then there's 15 here. That's all that's happening. I mean, that should be enough. Anyway. Alright. Absolute bullshit, he says. Okay, so how on earth does this intelligent receiver manage to pull off what you're proposing? Like I said, all the intelligent receiver has to do is be able to calculate a full wavelength time, cut it in half, measure how many photons it got in that period of time, and then measure how many photons it got in that period of time, and calculate the difference. That's all it has to do. That's all the intelligence it needs. Doesn't sound like it has to be that fucking intelligent. Alright, absolute bass. I mean, how does your receiver work? How does the zero, the signal everything, i.e. radio waves, light, heat, are, etc., etc. I don't know what that even means. I don't believe in radio waves, okay, by the way? Okay, I'm just saying that there's no such thing as waves. They're what would you call something that's in a, it's like soldiers in a, what do you call a bunch of soldiers in a group? You know, it's formations, they're clumps, they're groupings, there are lots of things, but it's not going through a medium. A wave goes through tension. A wave is something that travels through a medium. The photons aren't traveling through a medium. So you want to keep calling them waves, fine. That's what the traditional science does, because traditional science is full of shit, as I'm demonstrating. It's a wrong idea. It's not what's really happening. It has nothing to do with the facts. All right. And all the other radiation where we don't call them waves, okay, like light, more example, commonly, it's because, yes, that's not what's happening. It's a stream of photons. We understand that. It's not a bunch of photons waving. It's a bunch of individual photons. Alright, how does this zero, for comparison, not get mucked up? It does get mucked up. As I just pointed out, when there's two carriers, okay, it has to choose one of the carriers to be the time reference. And it does that. But that's all it's doing. I mean, it depends on how sophisticated the radio is, right? You can see that on a regular AM radio. A really fancy AM radio will be able to tune one signal in when there's one trying to interfere. And, you know, not so good radios won't be able to do that, because it won't be able to recognize that the timing cycle has to be adjusted to take the interference out. The interfering signal out. I mean, it's just like jamming radio. You can jam radio because you send the frequency and it bleeds the reference frequency. It bleeds into it by altering it slightly off frequency. By constantly going across the frequencies, it's constantly destroying the reference of the carrier. But who cares? That's not even important to this discussion. So again, why would any of this be important to you? The only part that's important is the fact that there's nothing interfering. There's no point you need to interfere the two waves together. They don't get calculated. You don't calculate the number of photons till they actually get to the receiver. And the receiver's calculating just how many photons, and that's all it's calculating. And it's just saying how big a difference is there from time 1 to time 2. How does the zero, for comparison, not get mucked up? How does the signal and carrier not get mucked up to an antenna that sees all photons? Well, like I've just said, it does get mucked up. But it doesn't mean it stops working because it's mucked up. It just says, I'll just go with this timing cycle. And as I pointed out, it's still going to do the math. And as it turns out, as it bleeds in, it depends on how much bleeding it's doing. It depends on how far it's bleeding in. So if it's still 3/4 on phase, if it's still 3/4 on phase, then only 1/4 off phase, then it's only going to make a little bit of a mess. But it just depends on how much it's bled off phase. I really think these are enough diagrams. I really think this is enough of an explanation. Yeah. A clarification. Further, more information. Now, how else to describe it? The signal can't do a trough. That's all you have to understand. So it has to send the information as all positives. You can't send a negative. You can only send 0 and up. So the negative is imposed by just recognizing that we're comparing the peak to a trough. The trough is here, okay, synthetically as nothing, as a blank space, and then there's another peak. That's what's being sent. So photons are being sent, no photons are being sent. Photons are being sent, no photons are being sent. Those are simulating the peaks and the troughs. That's creating the trough illusion. The drawing almost fits. I mean, it's a regular trough here. It says you could spill water down it. Anyway, so what's to say? It's simulating it by creating a pattern in time. The pattern in time is saying this is one thing of time. We cut it in half, and what we do is we measure how much we got here, and then we measure how much we got here, and we just subtract those two numbers. That's it. The end. Nothing complicated. And again, all of this is unnecessary to demonstrate the fact that what they're not doing is recognizing that there's signal still getting to the receiver when it's not making a sound. And that's the important thing to understand. Okay, I guess that's enough. Yeah, I think you should be able to understand this from what I've provided. If you can't understand it, then I'll have to do a 7th video. Yeah.